Anybody tell you different? See the little red light? Right there. Flash. White. Flash. White. Flash. White. Okay. So. Oh, my foot hurts. Okay, so what's the first distance? Who's going to volunteer it to me? Yes, Nino? Okay, that is correct, but we would never say that fraction because we would simplify it to what, Sam? 1/4 of an inch. Okay? Everybody with me?
Oh, yeah.
All right. Okay, what's this one? Who's next? Who's going to volunteer the next one? Jack.
We got 11/16 of an inch.
Yes, 11/16 is absolutely correct. Who's going to do the third one? TJ. 1 3/8. Absolutely correct. Fourth one, Nick. 2 13/16. Somebody stop him. And the last one, Sam. 3 7/16. Excellent. Now, how many of you are in woodwork or metalwork right now?
No.
So you all should know how to read one of these already, right? All right. What's different about the next set? These ones right here. What's different about this? It's in SI, right? Which means, are we going to have fractions?
No.
What do we have in SI? Decimals. Excellent. So what's this guy? 11.4. What's this guy? It's a tricky one. 13. Nice. Thought I would fool you with that one. What about this one? 16.7. Nice work. Everybody can do metric. Good. Now, what about these ones? These actually are tricky because I did something to mess with your heads. Sam. 4 5/8. But how did you know it was 5/8, Sam? Up on the top when I said the littlest ones are 1/16. Why did you know that was eighths? Because there's only 8 chunks in the middle. Yeah. Did I fool anybody else? I fooled you. That's okay. That was the whole point. All right. This one is 5 1/2. What's this one? 6 7/8. And what's this one? 7 1/4, which is, of course, 2/8. Yeah? Yeah. And then I gave you 2 puzzle sheets, everybody's favorites. Yes, yes. The math is the important part, everyone. Doing the math is the important part. Kids with mumps have a swell time. Because when you get mumps, your neck swells up. Have any of you had mumps? No, nobody should have had mumps. Yeah, get it? Kids with mumps have a swell time. I once had a sickness that they thought was mumps, and then I went to the hospital.
Was it meningitis?
No, it wasn't. They didn't know what it was, Jack. I had to be in a tent, and everybody that came in to visit me had to be in the whole disease. Dead serious. It wasn't even that. Well, actually, it was. It would have killed me, but they caught it in time. It responded to antibiotics. No, but the guy who decided what it was, hadn't seen it since World War II in London. And somehow I caught it.
That's a shame.
On the coast of British Columbia. Way over there. Nobody knows how I got it. And 4 other people on that little island where I was also got it. But I hadn't had any contact with those 4 people. Dum, dum, dum.
I walked into the supermarket.
Nobody knows what it was. No. Because when I say a little island, I mean a little island. There's no power, no water, no phones, nothing. It's like a summertime island where people go. And I had nothing to do with the people that all had it. We lived like a kilometer apart. We never saw each other. Nobody knows to this day. Crazy, hey? And if my parents hadn't got me to the hospital if they'd taken me even one day later, the doctor's like, he'd probably be dead. And then you guys wouldn't have me for math class. And then you'd be sad. But you wouldn't know to be sad because you never would have known me because I would have died in 1983. But I didn't.
It's a paradox.
Now, let's remember in 1983, you guys are all thinking, well, of course, 1983, nobody knew what it was. People still thought you put leeches on you to get better in 1983. They didn't. It wasn't that much different. But yeah, they had to wear the my little old granny had to wear a hazmat suit to come in and visit me. And she was like, I'm 75 years old. No sickness has gotten me yet. I don't want to wear it. But the doctors made her wear one anyway. My granny was hardcore. But then she died like the next year when I was in grade 5. Yeah. So she wasn't that hardcore. No, it was okay, man. She was 75. That's pretty old still. Right?
My grandma's like 78.
Yeah, but 38 years ago,
My grandma's 87.
right? 38 years ago, life expectancy was different than it is now. Right?
You're right.
I know. I mean, technically, once you pass 39, you're technically halfway past the life expectancy for a Canadian.
Don't like that.
So you could technically die at any given minute,
Not a fan.
right? Because life expectancy for a Canadian male is 78 years. Hey, be thankful you don't live in Zimbabwe. Life expectancy is 37.
Every time like 2 days.
37 is the average life expectancy for a man in Zimbabwe,
That's piece to see. I'm not living in Zimbabwe. No more.
right? Well, you wouldn't want to live in Zimbabwe. They have $10 billion money because their money is worthless.
Yeah, I know.
Yes.
So just down there, the absolute maximum a human being can live is around 115, 116 years old.
I don't know about that.
You're a person who lives 124.
That person's a god. More or less.
Next page. Next page. The only thing you left colored were left uncolored were the letters I and W. I
Warfare.
double U. 400 pounds, 800 pounds.
Infinite warfare.
Because he's double. No.
Stop.
I double U. It's a complicated pun, Jack. Talk to Amshuman. He'll straighten it out.
If Schumann, no, he doesn't stop
Yeah.
anymore.
Amshuman didn't get a lot of my jokes last year. And the whole class would be laughing, and he'd be like, and then the whole class would laugh for a minute, then the whole class would be quiet, then Amshuman would go,
He
oh!
doesn't get pop culture references.
He's better now. He's way better this year. What?
didn't know you were supposed to cross out the one, so you just had all the answers.
That's fine. Again, the math is more important than the riddles. The riddles. Okay, moving on. Chocolate milk is good
Yeah,
drinking.
live my life.
Okay, so let us begin. At the top here is all the stuff we're going to do this lesson. Now, guys, we are starting with converting units within systems. So we're going to be taking metric units, SI units, and converting them to different SI units. We're going to have imperial units. We're going to be converting them to imperial units. And the reason we do that is because it's easier to learn it that way. But the math we do when we later on convert from metric to imperial, the math is the same. So we learn the math with the easy numbers, and then you apply the same math when we learn the more difficult conversions. Everybody cool? All right. Now, the first thing I got to do is make sure you guys know what a couple of these words mean. Proportional reasoning. What does it mean if I tell you things are proportionate to each other? Can anybody explain that in plain old regular English? Nino.
They aren't abnormally sized. For example, if a human had a really big head and a really small body, it wouldn't be proportional.
Okay, you're doing it that way. All right, good. That's a good example. If I were to draw this, a picture, a stick person, and I drew it like this, does that make sense?
No. Yes.
Why?
Because that's abnormal for that head to be that.
Yeah, the head is wrong, right? Normal proportions for a human being, a body is about 7.5 heads tall.
Yeah.
Everybody cool? Same way if I drew this.
Ooh, baby.
That looks silly. Now, of course, if those two got married,
Their kid would be normal.
kid might be normal, but maybe not.
Be really messed up.
Or the kid could be really messed up. It could look like this.
But then you can play basketball.
Right? That would be no good either. Well, it might be good.
You
Anyways.
just take one step and get to Chilliwack.
Yeah. I should introduce him to that girl who's doing the math that way. Actually, Jack, it's interesting that you mentioned that because, of course, one of the very next things I'm going to talk about is that. But before we do that, I remind you all. So Nino pointed out that things have to be, if they are proportion, they work well in relation to each other. And that's what we're going to work on today, proportional reasoning. You have some amount of something, and that equals some amount of something else. Okay? And the other thing is, it always works. Okay? That's the first thing I want to point out to you guys. The next thing I want to point out is this one right here. I'm not going to highlight the whole thing. I'm just going to highlight... Whoa, good gravy. What happened there? I'm just going to highlight 2.4. If you read that to you, this is the important part. Reasonableness. Did that girl who was doing the math question for me do the fourth step here? Did she think if her answer was reasonable? No, of course not, because there's no way I could walk to Chilliwack in 15 steps. I could barely get to Nino in 15 steps. Okay? All right, so let's carry on. Now, this chart right here is part of a booklet you're going to get. I'm not giving it to you right now because the only part of it we need is this part, and it's right in your book right now. You do not need to memorize anything from this sheet. You are always going to get this sheet, okay? Because it's not about memorizing the proportions. It's about learning how to use them. Everybody cool? Now, as we practice, you are naturally going to memorize some of these. No big deal. But I'm not testing you on that. Everybody good? Okay. Now, I've left this big blank spot here because here's where you're going to write in how you do the math. All right? Now, listen to me closely. There is a million shortcuts to doing these problems. The problem with the shortcuts is they may work for Jake, but they might not work for Nolan. So if I teach you a shortcut and you don't understand the shortcut, you're screwed. Understand? So I'm going to teach you the way that always works and then let you figure out your own shortcuts. Okay? Everybody with me? All right. And here's how it works. To convert anything. So if you are converting between metric and imperial, if you're converting between imperial and imperial, metric and metric, if you are making any comparison between any two values, the math I'm about to show you is going to work. If you're comparing price to weight at the supermarket, this method will work. All right? That's how important it is to learn what we're about to show you. And here's how it works. You start with some amount to convert. So whatever your amount is, it doesn't matter what it is. That's what you start with. And then you always multiply by the fault. Yes, Riley?
Is it the latter?
No, it is not. But that comes into play as part of the shortcut you could learn, which I'm about to show you guys in a couple of minutes. You always do this. You multiply by a fraction. The fraction is always this. What you want over what you have. And that will give you your answer. Okay? And here is what I mean. What we're going to do is we're going to do the first one that we could all do in our heads. Then I'm going to show you how to apply the math to it. Okay? So let's look at that very first one that we can all do in our heads, right? 485 centimeters to meters. Well, we all know how many centimeters are in a meter. 100. So if I have 400 centimeters, how many meters do I have? 4. And since it's metric, I'm allowed to use decimals, right? 4.85. Do it in your head in 2 seconds, right, Jake? Yeah. Everybody could do that. So now that we know what the right answer is, because it's an easy one in metric, let's show you how the math actually works. Because even though this one's easy and we can do it in our head, if we learn how to do the math properly, when we're doing ones we can't do in our heads, it's still going to work. Everybody with me? So we start with the amount that we have. What is the amount that we have? We have 485 centimeters. 485 centimeters. Then we multiply by the fraction. What is it that we want? Meters over what is it that we have? Centimeters. Now we've got no numbers there, do we? Now we go to our chart. And when we go to our chart, we see what we already knew, that it's 1 meter to 100 centimeters. So what number goes here with the M? 1. What number goes here with the centimeters? 100. Now I just do this math. What's 485 times 1? 485. What's 100 times, what number should be down here? 1. What's 100 times 1? 100. And then I do the division. When I divide by 100, how many places does the decimal move? 4.85. Now, we already knew that, like I said, in our heads, right? But now, this is how the math works, and it will always work. So let's go to the very next one that looks slightly more difficult, but the math will work. What am I starting with? 57 inches. And I want feet. So what goes on the top? Feet. And what goes on the bottom? Inches. What number goes here? 1. What number goes here? 12. 57 times 1 is 57. 12 times 1 is 12. And I get an answer here. Now we're going to find something when we do this question. What happens when I do 57 divided by 12? You get a decimal, which is what? 4.75. What is wrong with that answer? That's not how you do feet. I'm 5 foot 8 inches tall. Do I say I'm 5.67 feet tall? No, I say I'm 5 foot 8. How tall are you, Jasmine? 6 feet? Okay, damn it. That doesn't work for me. I need somebody who has some inches in their height. How tall are you, Jack? 6'2". So does Jack say he is 6.167 feet tall? No, he says 6'2", right? So is that allowed for that answer? No. So how do I figure it out? No. We don't round it. What do I do, Nolan? I convert that to a fraction. So that's 4 3/4 of a foot, right? We still don't use that fraction. 3/4 of a foot is 9 inches, right? Because it's 9 out of 12. So this answer would be 4 feet, 9 inches. Is everybody cool with that? We don't use decimals. We convert it. Okay? Now, what if it's not a nice number like 0.75 that we know is 3/4? What do we do? No. What did I tell you about this math? Does it always work? Okay, so it really ruins my building of suspense when this does this. Not that any of you are really in suspense. You're like, oh, math sucks. But, you know, it kind of ruins my gig here. So if we have to convert one that's not pretty, like 3/4 of a foot, we can do that, no problem. What if I add 0.21 of a foot? Well, if I got 0.21 of a foot, I need that in inches, don't I? So I would multiply by inches over feet. 1 over 12. And I would do 0.21 divided by 12. Picking up what I'm putting down? Everybody cool? Okay. So let's have a look at the third one. Convert 15 yards to feet. What do I start with? I start with the 15 yards. And I multiply it by feet over yards. 1 yard, 3 feet. 15 times 3 is 45 over 1. So what's the answer? 45 feet. Now that should tell you a shortcut right now, shouldn't it? What did we do when the 1 was in the numerator? What math did we do? Division. What math did we do when 1 was in the numerator? Division.
Right.
What math did we do when 1 was in the denominator? Multiply. So there's your first shortcut. Right? Wherever the 1 is, that tells you if you're going to multiply or divide. Cool? All right. So let's look at this next one. What is weird about the way that it is written? There's one little tick right there, yeah? So what is that? Feet or inches? Feet. So I'll change colors so we're working over here. 136 feet. And I need yards. So I need yards on the top, feet on the bottom. 3, 1. So what do? Divide or multiply? Divide. What's 136 divided by 3? Can you do that in your head? 45.33 on your calculator, yes? And Sam says 0.33. I can't do that. So he changed it to a fraction like he's supposed to. 45 1/3. Right. Then he realized even that's not the best answer, and he changed it to 45 yards, 1 foot. Because 1/3 of a yard is 1 foot. Everybody cool? Everybody with me? All right. So let's have a look at this guy. What do we got to do there? 2016 inches, and I want feet. Feet over inches. So what number goes here? 12. What number goes here? So is it divide or multiply? So what's the answer? 168 feet. Exactly? Yes. Now, obviously this is one of those math problem questions, right? This is a math class question. Would you ever say to somebody on a construction site, go 2,000 inches over there? No, you would use feet, wouldn't you? I live, 36 kilometers from here. Would I ever say, I live 36,000 meters away from work? No. Not even me as a math teacher would say that. Riley? Any what? No, I only have paper towel, which makes my nose hurt, but you're welcome to use it if you want. Please do. What is wrong with number 6? Why is it written in a strange way? TJ? Pardon me? It has both systems, does it? Miles to feet. But you're on the right track. It has something to do with that. Nina? It has a decimal. So it looks different, and it's written in a way we shouldn't use it, right? But just because it looks different, are we going to do our math any differently? No, because looks don't matter. So we still are starting with 4.2 miles, and we want feet. So we want feet over miles, and then we go to our chart. What's the answer? 1 and 5,280. So I multiply 4.2 by 5,280, and what do I get? Nobody wants to say it because it's got so many numbers. Everyone's going to say it wrong. They're worried about saying it wrong. What is it, Aiden? Because he put his hand up. 22,176 feet. Now, again, math class question, right? If I was saying I was going for a 4-mile run, I would not say, I'm going to go run for 22,000 feet. Because that's stupid. But math teachers like to use it. But the only reason you get questions like this in math class is to show you that it doesn't matter what it looks like, that the math always works. Is everybody with me? Can everybody do these easy ones? Any questions? It's super easy, yes? And it doesn't get any more difficult if you follow along. Turn the page over. And let's check out number 7. We already know how to start it. What do we start with? 5,250 yards. What do I want? Inches to yards. Do I have that comparison on my sheet? What is it? 36 to 1. The 1 is on the bottom. So what math am I doing? Multiply. Multiplying what, Jashin?
5,250 and 36.
Exactly right. What do we get? Sam. 189,000 inches. Again, a math class measurement, right? Not a measurement you would ever use in real life. Okay, so number 9 should be no problem. Number 9 you should be able to do in your head. What is it? Oh, duh, I forgot about 8. 1250 millimeters to centimeters over millimeters. What is it? 1 centimeter is 10 millimeters, yeah? So where's the 10 go? Is it divide or multiply there? Divide, so it's 125 centimeters. Now we'll do number 9. TJ. No, TJ. Now, no, I'm glad this happened. TJ, why do you say 395? Did you try to do it in your head? Without writing anything down? Yeah. How'd that work out for you? Right. 37.25 meters times, I want centimeters, cm over m. 1 meter is 100 centimeters, right? Now, TJ, did it make sense to say 395? No. So should you have said it out loud? That's the 2.4 thing, right? Check the reasonableness of your answer. How can 337 only be 395 when you got to multiply by 100, right? Picking up what I'm putting down? So how many decimal places does this move? 2. So it's 3,725 centimeters. Okay? Now, I'm not trying to put you down, but this is good that this happened, right? But this is what I mean, right? Check your answer. Make sure it makes sense. Now, what's wrong with number 10? Oh, yeah, it's idiotic. It's idiotic. But you know I have it there for a reason, don't I, Aiden? Right? There is a reason as a math teacher that number 10 is there. Riley?
I tried to do that one on my calculator and it didn't work.
Yes, absolutely.
0, 0, 1, 7,
00172. You don't have enough zeros.
Would it be over 4 or would it be over 5?
We're going to talk about it in a sec. You can do this one using your brain, right? Because you know every step on the metric system moves the decimal place 1 spot, right? So if you've memorized all the steps, do you know how many places you got to move it? It goes kilo down to, who remembers the one right below kilo? Starts with an H. Hecto. What's below hecto? Deca. What's below deca? Meter. So there's 4 steps. And then what's below meter? It's another D1. Deci. That takes us to tenths. And then I need what's after tenths? Hundredths, which is centimeter. And what's after centimeter? Millimeter. So I'd have to move the decimal 7 spaces if I know all those names. Right? What if I forget those names? Can I still do it?
Yeah.
I can. Because I know I need to go millimeters to kilometers, right? So look on my chart. What do I have that has millimeters? Right there, I can go millimeters to centimeters, can't I? So let's go back to where we start. If I go 17.2 millimeters times, I go to centimeters first. 1 centimeter is 10 millimeters. Agreed? So now here I am at centimeters. But I don't need to go to centimeters. I need to go to kilometers, don't I? Can I go centimeters to meters? Yeah. So now I want meters from centimeters. And it's 1 to 100. Agreed? Everyone cool? And then I want kilometers, right? So I want kilometers, and I need to be over 1,000. Is everybody cool? And if I do that, will I get there? There it's going to move 2 decimal places, 1. There it's going to move 2 more, and there it's going to move 3 more for the total that I need. Is everybody cool? Did I need to memorize the seven levels? No, because I can always do the long math, right? So how far does the decimal have to move here? 1. How far does it move here? 2 more. What goes in the hole? 0. And then how far does it move here? 3 more. 1, 2, 3. And what goes in the holes? Zeros. Is everybody good? That's the basics. So let's do some real life problems with it. Look at question 11. What measurements do I have? I have feet and inches. The question wants to know what? How many inches? So do I even care about this right now? Why not? Because it's already in inches. So I don't need to worry about that. But do I care about this? That I got to fix. How do I do it? "12 inches over 1 foot," because what I have goes on the bottom. Numbers on the bottom, so I multiply. What do I get? How's your 12 times table? 72. Plus what? 4 to get. And that's the type of real life problem that you would have to do if you were building something. Because we still do our building in inches and feet. Don't ask me why. Canada's been metric since 1970. Here we are, 47 years later, we're still building houses in feet and inches. Okay, what's next? What do I have?
5 yards, 2 feet.
I got yards and feet. What do I need?
Inches.
Inches. So I got to do 2 conversions, don't I?
Yeah.
Does it matter where I start?
No.
No. So what do you want to start with?
5 yards.
Yards? Okay, so I got 5 yards, and I need inches is what I want, and I've got yards. So what numbers go where? 36 inches, 1 yard. Now, are we to the point where we don't even need to write the 1 yard? Maybe. But if you're not, does it matter? Of course not. The 1's on the bottom, so am I multiplying or dividing?
Multiply.
So what is it? I'll help you out. 180. And then I got to do feet. 2 feet. And I want inches over feet. So it's 1 to 12. So what's that? 24. What do I do with those 2 numbers? To get 204. Everybody good? All right, number 13 is a bit of a trick question. No, there is a trick to it. Everybody try it on your own while I have a sip of my green tea. Ah, I'm out of green tea. Fortunately, I have a pot over here. Hey, I'm getting some tea. Just wait a second. Oh, go to the bathroom. Would anyone else like some green tea? I have a little bit left. Oh, I lie.
I'll drink it straight out of the pot.
No. Gross. You drink out of the milk jug at home too? Yeah, you do. How many of you drink out of the milk jug?
But it's almost empty.
When your mom sees you?
Yeah.
She doesn't care.
Your mom doesn't care?
Yeah.
Because it's almost empty.
Oh, well, when it's almost... Okay, let me change the question. How many of you drink out of the milk jug, leave a bunch of milk in it, and then put it back in the fridge for the next person to drink out of? Yeah. Okay, and I bet a bunch of you do this too. You drink out of the milk jug and you leave 1 atom of milk in it. And then you put it back in the fridge. And you say, I didn't empty it, Mom. It wasn't me. How many of you do that one? Good. My kids do that all the time. Well, I didn't empty it. I shouldn't have to throw it out. Yes, Sam?
I think kind of my sister's Dr. Pepper, but I'm glad that she wasn't very.
Of course you do, your poor sister. Now she's got your cooties all in her Dr. Pepper.
No, she finished it. She wasn't sharing it, so I took the sip and just put it back in the fridge.
That's your sister's Dr. Pepper.
Yeah, I shared my house with her.
Yes. All right. So what do I got to do?
6 times 36 divided by 5.
6 yards times 36. Because I know I don't need the 1, do I? Equals what? 216. And then what did you do, Sam? You divided by 5 because you had 216 inches and each banner is 5 inches wide. So you had to take your 216 and cut it into 5-inch strips. Cutting is division. Now, Sam, what did you get for an answer?
43.2, but you can only have 43 banners plus a remainder of 22 inches.
You don't have to worry about that. That's the point, right? That's why the question has a trick. How many banners can you make? 43. End of discussion. You can only make 43 banners, right? So if you were to ever get a multiple choice test, guess what choice A would be? 43.2, because that's what would be showing on your calculator. That requires you not to think, right? And how many of you would circle A? Be honest. A whole bunch of you would circle A. And then I would make D 43.
I took D.
Some of you would. Now I'm really going to mess with your head. What if I told you that there were 220? No, I lie. 221 inches of fabric. What would you do? You would still divide by 5. What would you get for an answer? Do that with your calculator. What would you get? When you do that with your calculator, what number do you get? Excellent. So how many could we do? 44. Excellent. What if it was 219? Do it with your calculator. 43.8. How many of you would round that to 44 automatically? Not anymore. But if I'd asked this question 5 seconds ago, Jashin, would you have rounded that to 44? Yeah, of course you would, right? Because we're taught that in grade 5, right? Once you get past 5, we round up. But do I get to the 44th banner? Of course. Don't worry, Jake. By this time next week, I put up a little chart. You can only go to the bathroom twice all week.
Okay.
What?
Yeah.
Including at home?
No. You can leave my class twice in a week.
But we leave it 5 times a week.
Okay, Sam.
Class.
Okay, Sam. All right. Look at number 14. What's the question asking?
Convert into kilometer at 2
So what do I need to do? Exactly. That's the point. Aiden, is there a right way to do it?
No, as long as you get the right answer.
As long as you do something, right? I have to either convert that to what? Meters, or I have to convert that to what? Kilometers. There's 2 right answers, yes?
Yeah.
Do you have to convert both? No. You don't have to convert both. Understand what I'm saying? If I convert this one, it's 2,000 minus 755, right? If I convert this one, it's 2 minus 0.755. And you'll get the same answer, won't you? Doesn't matter which one. What's different about number 15? There's 3 different ones. So I got it. But what did I do right here? I want it in kilometers. So what one of those do I not have to touch? I don't have to touch 1.35. He's perfectly fine. Do I got to change that one? Can I change that in my head yet? Meters to kilometers. How many zeros? 3, because it's 1,000, right? So this guy, Jashin knows that this decimal's got to move 3 places. But what if you don't remember that? Do you have something that will do this for you? You can still use the fractions, can't you, Nick? You could still go, if you forget that it's 3 decimal places, you could still go 125 times km over m, 1 over 1,000. Oh, right, divide by 1,000. Oh, okay, I got it. Right? Now, how do I do 40 centimeters to kilometers?
Are you segmenting?
Yes, I'm so happy! Nobody gets that!
What?
I've been using this question for 10 years, Sam. Nobody has gotten that. Everybody says, well, I gotta convert it, then I gotta convert it, then I gotta convert. Isn't this right here 125.4 meters? And don't I only have to move the decimal 3 places?
How do people not get that?
Nobody has ever said it, Jack. Ever. Everybody says, well, I gotta convert and I gotta convert. Yunji? Yeah.
Well, that's how you probably do it.
Oh, now I do need Kleenex. I'm so happy.
Maybe it's the right try. Way to go.
No, they're tears of joy.
Don't be a white girl.
Oh, okay, phew. Oh, that makes the guy happy. So, knowing what you know now, will that apply to number 16?
Oh, yeah.
Definitely not.
No.
Why not? Because Imperial's dumb. Right? I want the answer in yards. So what do I got to change?
Oh, I got change all your miles.
I got to do miles and inches. So miles, I got 4 miles and I need yards. So yards over miles. 11760. So what do I get there? The one's on the bottom, so it's multiply, and what do I get? $7,040 plus 12, 7,052. Now, 13 inches. Right. 13/36 of a yard. Is that okay?
Always.
Is it? Is that the right answer? Is 13 inches 13 out of 36 of a yard? Is it or isn't it? It doesn't sound good, but is it right?
Yes.
Yeah, because it's 36 inches in a yard, and I've used 13 of them. Is that okay? So that, if you answered this question that way, you get the A. Everybody understand? Because it's the right answer, yes? Is there a better way to write it? Can you make it prettier? Jack just did it and Sam just did it, right? Jack said it earlier, but he just said the answer. And Sam is saying what he did. He turned this into feet. So Sam says it's 7,052 yards, which is going to show up in a second. One foot and what? 1 inch. And this gets you the A+. You picking up what I'm putting down? They're both acceptable. Let me give you a hint for the rest of your math career. If you can ever Make it look prettier. Make it look prettier. Everybody cool? Okay.
Is it possible to get A plus in this course?
No.
A plus is not.
All right. Number 17 is done wrong by at least half the class every single time.
Oh, that's
Go.
like a good thing.
Ah,
Try number 17. Go.
Aw. Delicious. Thank you. No. She's not making that face.
Hey, Mr. Dewey Duff. Pre-diploma 10? No. This is Form 10.
Oh, this is Form 10.
Yeah.
Interesting.
So, of course, that is a wonderfully rendition drawing of myself.
Looks a little bit like Bill at times, guys.
Right? And that picture, I'm so gorgeous that I want a picture of myself on my wall that is 3 feet by 5 feet. Right? So, 3 feet by 5 feet, right? But I needed in inches, so how much frame do I need, Nino?
Oh, you know what? Never mind.
Okay, how many feet do I need, or how many inches do I need, TJ?
Wrong.
Sam, what's your guess? 192. Isha, what's your guess? 60 inches, what's your guess? 16.
I said
16.
16.
Jack?
180.
180. Okay. We're all over the map, aren't we? Why? Huh? 90. Nobody guessed 96. Okay.
5 plus 3.
All right. So the frame goes around the whole picture, yes? So how much do I need there? I need 5 feet, right? How do I turn feet to inches?
Imagine we can get 6.
Times 12 to get 60, yes? What do I do here? Times 12 to get what? 36. So Nick says I need 96, but Nick, that's only half my picture. What do I got to remember to do? Multiply by 2. So it's 192 inches, yeah? Now, what happens with number 18?
no.
Nope. Don't need the same amount. You just need deeper stuff.
Oh no, it's broken. I hate it when this happens. It shrinks my head because, as usual, it's broken.
And it's gone.
Yep, my head's gone now. Anyway, while we're waiting for this to fix itself, how many people think it matters?
Depends if there's a change in price for the thickness of the frame.
Wow, that's impressive. I can't even close it that way. That's a new low. There we go.
Oh, it's a collage.
A collage. Yes, it is a collage. There is still work, but I bet my picture is gone. No, there I am.
You took Ant-Man, his head shrunk.
Anyway, does it change? Oh. Now half my head's gone. Now my whole head's gone. So that's still 5 and that's still 3, right?
Yeah.
So this is still 60 and this is still 36, yeah? But now the frame is 1 inch thick, yes?
But it's a price, right? It's not asking how much frame you need anymore. It's more about
How do you draw a frame? There's something wrong with this question. What does it assume that you know?
It assumes that you already know the amount of how much the frame costs.
No.
Would the frame change if
It assumes that you know that the depth,
one inch
what the
thick?
depth of the picture is.
Not quite. But you're on the right track. It assumes you know how a picture is framed, yes? What does a picture frame look like? If you don't know, are you in trouble?
No. It's square or a rectangle?
It's a rectangle, yeah? But how does it meet in the corner?
It's perforated.
It meets at 90? There's a frame right up there around the bulletin board. How does it meet?
The two edges connected?
Then the two edges hit like this, yes?
Yeah.
Okay. Like that, yes?
Yes.
Okay, so the frame must look like this, correct?
Yes.
So if this is 1 inch thick, how long is this part of it?
Still 36 inches.
36 for this part, because the picture is 36. How much do I have to add right here? 1 inch. How much do I have to add down here? Another inch. So my 36 becomes what? 38. What about this way? This part of it is 60. What do I add right there? 1. And what do I add right there? 1 inch. So it's 62. So it becomes 100. And I got to do that how many times? Twice. So it does change, doesn't it? Why was this question a bad question? Because I took it directly off an old provincial exam. What's wrong with it? Is this knowledge about how a frame works part of math class, or is it part of life?
Part of life.
And this is a class in what? So it's a bad question. Does everybody understand? Okay, look at the next question. What's wrong with it? Because my computer's frozen again, so you're going to have to wait a minute. What's wrong with the next question?
It assumes that you know crown molding works.
It assumes you know what crown molding is. What's crown molding?
It's that nice white mold, well, typically sometimes white, that you put around your house to make it look all fly.
Around what part of your house?
The up top and the bottom.
Right. It's where the ceiling meets the wall. So if you're in somebody's house, look up at where the ceiling meets the wall. If it looks like this, wall ceiling, then they don't have crown molding. But some places have a piece of decorative, usually shaped like that goes around the ceiling. Do I have it?
No.
Look closely.
I just realized I'm hiding.
Do I have it?
Yeah.
Do I have a piece of wood between where the wall and the ceiling meet?
Yes.
Yes. So I have crown molding. Does every house?
No.
No. So if you don't know what crown molding is, could you do this question?
No.
No, it's a horrible question. It used to be on a provincial exam. What else is wrong with that question? There's 2 things wrong with it.
The caustic molding?
It doesn't tell you what a linear foot is.
You don't know what a linear foot is. It assumes you know. What is a linear foot?
1 foot.
1 foot, no matter how big it is. The piece of wood could be this big, but you buy it by the foot. Or the piece of wood could be this big, but you still buy it by the foot. Because a linear measurement is a straight line. Does everybody understand? Is my height a linear measurement? Yes or no?
Depends on if you have scoliosis or not.
I'm glad you mentioned that. Sad that you would, try to make fun of people with scoliosis.
Oh,
But
I haven't. I'm not making fun of them.
more importantly, even if you had scoliosis, is your height still a linear measurement?
Yes.
Because how do you measure your height, Sam?
Wall?
On the wall, from the bottom of your feet to the top of your head, right? Is that a straight line?
Yes.
If I was a skinny little twig person, would my height be the same as if I were a big giant football player? Yes, because the measurement of height is a straight line from bottom of my feet, top of my head. Everybody cool? So how do I do this question? Now that we know that it goes around a ceiling, how many walls are there in a room? 4. So what do I have to do with both of those numbers? Multiply them by 2. Now, could I add them together and then multiply by 2? Yeah. Right? Because it's a straight line, yeah? So if I do all that math, how many inches of crown molding do I need to buy?
But you need to divide by feet. So you have to divide by 12.
Eventually you will. We've got it in inches, so we're going to add them and multiply. multiply by 2, right? So what do I get? 480 and 370 is 850. Yeah. 850 inches. But it's sold by the foot, so what do I got to do with that? Divide it by what? 12. What do I get then? 70.83. So how much crown molding do I need to buy? Read the question. It's sold by the what, Nick? By the foot. So how many do I need to buy?
71.
I need to buy 71 feet. Does everybody understand? What?
Construction really helps with that as well.
Yeah.
It's like just going on with it. Also for the wood, you wouldn't say, oh, I need a linear foot or something. You have to say, oh, I need a 2x10 or 2
Yeah.
something like
Yeah.
that.
Yeah.
So if you say, oh, I just need a linear foot of wood, that everyone would be like, what? I need
Yeah.
to decide.
Absolutely right. Absolutely right. But some things are sold that way. I'll give you an example.
If you have one size.
Yeah, borders are often sold by the linear foot.
Yeah.
So 71 feet times what? 3.79 to get your answer. Everybody cool? All right, I'm going to shut up. Your homework tonight is page 20, 21, and 22.
Oh my goodness. Whoa.
Go.